Hello, welcome to today's webinar. My name is Gregor Pipan. I'm head of marketing at CGS Labs. And today we will host you together with my colleague Petra Tihole, a CGS Labs support engineer, at the webinar BIM approach in the design of intersections. First, let me share with you some information regarding today's webinar. So the session is being recorded and the content will be shared with you later on after the webinar. And you are also welcome to ask questions. For this purpose, you can find the special section in the webinar dashboard called questions. Just type your questions there and we will try to answer them at the end of the webinar so that we don't disturb the webinar during the session, because there are a lot of attendees at this webinar. So let me first say just a few words about CGS Labs and our products. We call ourselves a laboratory of ideas. We develop software that help digitalization of built environment. We have been in this field active for more than 30 years now, and we have a lot of experience in developing software for infrastructure design and maintenance. We also have a very strong environmental department where we develop, for example, road weather information systems to help winter maintenance services. And we're also involved in the development of BIM and active in building smart activities and contribute to development of standards in the field of digital infrastructure design. About our product portfolio, today we'll focus on the products for civil engineering design. We have solutions for 3 categories: for road infrastructure design, which is also focus of today's webinar. Then we have railway design and maintenance, and then we have solutions for river and channel engineering works design. So maybe to go a bit in this road infrastructure design and maintenance, we have our main product, Plateia, which is BIM ready solution for road design and reconstructions, and it's kind of all-encompassing solution for road design, and it covers every aspect of road design, from survey data, terrain, and then to design analysis and so on. Then we have supporting products, as is AutoSign, a specialized product for traffic signalization. And then we have, for example, AutoPath, which is a product for swept path analysis and vehicle turning simulation. Already mentioned is railway design software, Ferrovia, and also a software for channel and river engineering works design, Aquaterra. If we say a few words about Plateia, which will be focus of today's webinar, Plateia is a BIM-ready software, which means that you can add all the data you need to the design 3D model of the road, and then exchange this model using IFC data with other software in your BIM workflow. Plateia has a very intuitive user interface that is based on the established design process. And you can, as mentioned, use the software for any kind of road projects, no matter the type or size of the project. There are several advantages of the software. Maybe let's just emphasize a few. It's a complete tool for the design, so you can design the geometry, you can do the analysis, and you can prepare all the documentation. It supports standards, localized standards, as mentioned, it has established design approach, which is very common in civil engineering. So civil engineers are very fast to learn how to use Plateia. It enables 2D, 3D design and also supports BIM workflows and BIM approaches, which are now used more and more in the engineering practice. If we go further, you can see that areas of application of Plateia are very diverse. But today we will focus mainly on the design of intersections and through the BIM perspective. And who are the users? As mentioned, road designers is the main focus groups, but Plateia is also used by surveyors who prepare the data for the designers, and also by contractors who monitor the designs and are actually involved in the construction of the actual projects. So now I would like to hand over the floor to my experienced colleague Petra Tichole, who will show you how to design intersections with BIM in practice. Please, Petra, take over. Muted, see.
Thank you, Gregor, for this interesting introduction. My name is Petra Tichole, and I'm a technical support engineer at CGS Labs. First of all, I would like to thank everyone who is attending the webinar today. I'm super excited that this webinar has attracted so much attention that we have designers from all over the world with us today. In this technical part of the webinar, I will present the approach to designing road intersection BIM models using our software Plateia. Plateia is our professional software solution with a huge number of different tools, which is the end user experience to the highest possible level. Moreover, Plateia enables project modifications, which did not used to be as self-evident as it is today. So imagine that you are a young civil engineer in the 80s. One Friday morning, you are enjoying a cup of coffee and thinking about where you will spend the weekend when suddenly your boss comes into the office. He says he hasn't slept well and wants you to raise the road profile by 10 centimeters. If today that means 2 mouse clicks, it used to mean that you had to manually correct up to 1,000 cross sections. And if your boss had one bad night, your team definitely had at least 10. Based on such cases, the idea of developing road designing software was born. The team of developers started with the aim to transfer the classic design concept from paper to computer using basic geometric elements such as lines, arcs, and circles. Such a 2D computer-aided design made it possible to significantly simplify and speed up the planning of infrastructure facilities. Later, due to the desire for even more efficient design, 3D modeling began to develop. It enables us to have a better overview of the model, which reduces the possibility of errors compared to the classic drawing of 2D plans. In recent years, building information modeling has become established as the most successful design approach. BIM is the design concept that is no longer based only on the geometry of the models, but also on the information attached to the elements. So information is the key component that separates a BIM model from a 3D model, as it brings many advantages compared to classical design. It is getting more and more attention internationally. CGS Labs software has enabled BIM planning for several years now. The biggest advantage of using Plateia for BIM projects is that the BIM approach is very similar to the classical design. In addition, the tools are very simple to use as the user interface is designed very carefully. This means that you don't need to learn a lot of new things and still quickly upgrade your plans into BIM models. The next advantage of using our software is the creation and editing of cross sections. In addition to many features for drawing typical cross-section elements of the road, Plateia also enables you to draw custom elements which you can planimetrify and draw as a 3D model. So let's see what's meant by that. Plateia creates a 3D model by connecting planimetric quantities between individual cross sections. So each road element that you want to draw as a 3D solid must be drawn as a planimetric quantity in cross sections. This means that with features from the cross-section tab, you can draw and planimetrify a custom complex shape, while it can be then drawn as a 3D solid. And you are not limited by typical elements from libraries as you are in other programs. Speaking of cross sections, I would also like to mention our macro. This tool allows you to save any cross sections to a library and reuse it on another project. And when it comes to special functionalities for BIM projects, we must highlight the collision detection tool. With standard programs, you usually have to export IFC first and then check for collisions in some other environment. While in Plateia, you can do this directly within the software. And when collaborating with other experts in demanding projects, tool for attaching attributes and IFC export and import will back you up without limitations. For all this reason, Plateia is popular among civil engineers that work on BIM projects. To further improve the BIM approach, we often set up demo projects to test the capabilities of the Plateia and Ferrovia software. On the basis of these projects, we can search for improvement possibilities based on the upgrade of the existing ones and on the development of new functionalities. At all times, our focus is to maintain the designing process as it is, simple and clear, as we want to avoid any unnecessary stress. Through 5 key steps, I will teach you today how to create a BIM model of an intersection and show you how to create 3D models of islands and traffic signaling. Finally, I will explain the advantages of exporting a model to IFC and to what you should pay attention when designing a roundabout. In doing so, I will use the existing commands and I will also include some new functionalities that we have developed in the last year. This can help you work even faster and have more options available. I will also show you how to attach property sets to attributes, to property sets of attributes to elements, and what is important when defining them so that you can then correctly connect the models to the quantity takeoff. Now let's start with the design of a three-way beam intersection. The first step of creating an intersection is preparation. By that, I mean inserting terrain, creating two alignments that intersect, defining sample lines, drawing a profile, and calculating super elevation. This step is always the same, no matter if you are creating a 2D plans or a BIM model. In this example, the major alignment is axis 1 and runs in this direction, while the axis 2 represents the minor alignment. After that, we move to the second step, which is creating an intersection surface. We do this with a dedicated tool found in the Traffic tab. This functionality significantly accelerates the intersection designing process with automatic adjustments of the slope and super elevation of the minor alignment according to the major alignment. Besides, the alignments of the fillets and their longitudinal profiles are drawn automatically. Okay, to run the command, click on the Traffic tab and then double-click on the intersection. First, define the parameters in the left part of the dialog box. Type the name of the intersection and then select major and minor alignment from the drop-down menu. Then select the existing ground, the existing terrain, and define the intersection surface name. After that, specify parameters for individual fillets. This tool always offers to draw 4 fillets. Since we want to create a freeway intersection in our case, we will exclude 2 of them. We can also help ourselves with a sketch. If the fillet is possible, the software automatically shows it in the layout. So let's define the parameters of the right fillet. First, check whether the software set the right entry and exit lane. In this case, everything is okay. Otherwise, we would select different lanes from the drop-down menu or directly in the drawing. Then select the fillet type. The user has 3 options. We will select the arc option and we will define the radius. After that, we have to define the fillet alignment name. In this example, we will name it after the site. However, for larger projects, be careful to name the fillets in a meaningful way because it will be easier for you. After that, you select the grading criteria and then press to the arrow to move to the next fillet. This fillet doesn't exist, so we uncheck the draw fillet box, and we do this the same for the third fillet and move to the last one. We check the entry and exit lane again, and then we select the fillet type. Okay. Then we define the radius and define the name and select the grading criteria. Okay, then we click on the settings button. In this dialog box, you can define some additional settings for fillets, for vertical alignment and super elevation on minor alignment. In this example, I will leave default values and then I will select a surface type. Select CGS DTM and then check at the triangles box and uncheck the boundary option. Press OK and then click somewhere on the drawing to define the insertion point. Plateia automatically draws the surface and profiles. It has also changed the profile of the minor alignment. If necessary, the profiles can also be edited manually at this point, and then the surface of the intersection can be refreshed with the refresh intersection command. After you have finished creating the intersection surface, you continue with defining projection lines. To be able to define these lines, however, you must first decide how you will create the intersection model. This means dividing the intersection into meaningful parts. The BIM model of the blue and purple part will be created on the basis of fillets that we were automatically created in the previous step. Those 3 yellow parts will be created based on the cross sections for axis 1 and pink parts on the cross sections for axis 2. Now let's focus on the blue part. When we used the intersection surface command, we got the left fillet alignment, which is highlighted in red in the right image. The height of the left edge, marked in blue, will be obtained in the next step with a 2D projection onto the surface. This newly created 3D polyline will then be inserted into the cross sections, and by connecting the fillet axis and the 3D polyline of the left edge, we will get a top surface of the pavement. Okay, to make it easier for you to understand, let's move to the drawing. First, we draw a polyline at elevation 0. And after that, we will select this polyline and we will run the polyline editor command, which is a new tool that allows you to project a line onto a surface. So I created a polyline. I will now select it and run the polyline editor command. Okay, now I select a 3D polyline in this dialog box and select the option raise to surface elevation. Now be careful that you select the intersection surface and not the terrain. You can now notice that a new 3D polyline is now inserted in the drawing. Then you have to define this polyline as a projection line because that's the only way to insert it in cross sections. Okay, and after that, we repeat the same procedure for the right fillet. So we draw another polyline. Be careful that you draw this polyline at elevation 0. Okay, then I select this polyline and run the polyline editor again and project this 2D polyline to the intersection surface. After that, we shouldn't forget to define this polyline, this 3D polyline, as a projection line. Now, you can start by drawing a 3D model of fillets. First, define one randomly wide traffic lane for the left fillet. The only reason you need to do this is that the roadway will be inserted in the cross sections. Without the roadway, you cannot see the axis height in the Plateia's cross sections. So you run the alignment manager, then double click on the left fillet to make it an active alignment, and then double click on the lanes. Click on the add and define the label and the width. Okay, after that, you have to refresh the layout. So you have to run the calculate expansions and draw lanes command. Press OK, and you can see that a new traffic lane is now inserted in the drawing. Then you draw sample lines a distance of 1 meter and one additional sample line at the intersection between the major and minor alignment. This additional sample line will allow you to draw the 3D model perfectly over the entire area of the intersection. Otherwise, there will be a small gap in the middle of the intersection. So you run the draw sample lines command. Define the distance between cross axes and with left and right. Press OK. And then run the sample lines through a points command. Click on the icon next to the station, and then click on the intersection between the major and minor alignment. Then you have to refresh the longitudinal profile. So go to the Profile tab, click the Refresh Profiles, and now those sample lines will be shown in the profile. Now you can start creating cross sections, which are the basis for creating a 3D model. You run a draw cross section view. Then you check the parameters and press OK. If I zoom in the first profile, you can see a drawn traffic lane, which I have defined in the alignment manager in one of the previous steps. In order to get the top edge of the roadway pavement, we have to first insert the previously defined projection line. Okay, and now you click on the line command and connect. Okay, and now we will connect the right edge of this lane with the projection point. This line now represents the top of the roadway pavement, and you can now continue drawing typical cross-section elements. I will start with the pavement, and then I will add the curb, sidewalk, bicycle lane, shoulder, and embankment. At this point, I would like to remind you once again that all elements must be planimetrified if you want to draw them as 3D models. If you may not be the most skilled at the drawing and editing cross sections, please check out the basic training at CGS Labs Academy, which you can find on our webpage. Unfortunately, we don't have enough time today to draw each typical cross-section element together. So I have prepared a macro to run it. You just simply click on the play macro and then select it from the list of macro definitions. Now that all my cross sections are complete, I can draw the 3D model. So I go to the Utility tab, click on the Draw 3D Model command, and then I specify which quantities should be drawn and confirm by pressing the OK button. Okay. You can now see that the 3D model of the left fillet is now complete. Then you draw the 3D model of the right fillet, and in the same way, but for other parts of the intersection, you have less work because you don't need to insert projection lines since you already have all the road edges. So now we created a 3D model, but if you want to create a BIM model, you need to attach metadata to the 3D models. In Plateia, property sets are defined in the property manager. The user has two options: automatic attributes, which values are calculated and inserted automatically after drawing a model with the Draw 3D Model command, and attributes that are defined and attached manually. In addition, it has a tool for viewing and editing attribute values. So let's take a look at this process of editing property sets directly in an example. First, we need to define property sets in the property manager. To add a new property set, click on the plus button on the left and then define the name. Okay, I defined a surface course for the name, and then I press the OK. Afterwards, click on the plus button on the right to add attributes. Define a name and then select a property type. If you choose the user-defined option, it means that you will have to enter the attribute values manually. We enter the default value in cases where we know that it will always be the same. In other cases, we prefer to enter it manually using the property set editor command. If you choose one of the other options for property type, the program will automatically insert the value of the attribute after we run the draw 3D model command. Information about which attributes you needed to attach to an individual model or to an individual element can be found in the BIM execution plan. So you can see that I clicked on the plus button, I defined the name, and this time I select a user-defined option for the property type, and I also defined default value because this value will always be 5 centimeters. But if I want an attribute for start station, then I select start station property type, and the software will automatically insert the value. Okay, once you have defined all the property sets and arranged the cross sections, you can create a BIM model. After running the draw 3D model command, you define the source data, then you select the alignment and select quantities. Okay, after selecting the method. Then define the corresponding property set for each quantity. Okay, for example, this property set curve we defined in a previous step in the property manager. Then you can also check the box at the Align option to connect the consecutive planimetry polygons along the alignment. Otherwise, it connects the adjacent planimetry polygons with sectional straight lines. With the help of the property set editor, you can check whether the property sets have really been attached to the model. So you select a model in the drawing, and then you see which property set is attached to this element, and you can also see the values of the attributes. You can also, with this tool, you can add more property sets to one element. For example, a property set with project data. Now let's take a look of creating the island. In the beginning, you have to draw a 2D polyline that represents the shape of the island. This polyline is created by using CAD commands and should be at 0 elevation. Next, use the grading tool to project this polyline to the intersection surface. And at the same time, additional 3D polylines will be created, which will represent the edges of the island curve. Okay. After that, I will isolate those 3D polylines. And I will create surfaces between them. To make those surfaces, run the make single surface command, select 3D polylines, and the surface between them is created. Then you repeat this procedure for all the polylines. And once you have connected all the 3D polylines that represent the curve, you can select all the 3D faces and assign them the same custom defined layer. Okay. Alternatively, you can draw the surface using the terrain tool. So this time I will hide other 3D polylines to make it easier to understand. I run the terrain command. Then I define a new surface. Okay, select a 3D polyline in the drawing, and then I will also select the boundary. At the end, you can also change the color of the layer to green. So this is the last step of creating an island. Okay, we will also show the curve. Okay, and the island is completed. To make our model totally complete, we conclude with drawing a traffic signal model. The fastest way to create it is in the AutoSign software. AutoSign includes extensive libraries of traffic signs and road markings for individual countries, and at the same time offers tools for creating user-defined traffic signals, thus allowing the designer more freedom in designing. In addition, it allows us to convert 2D traffic signaling into 3D models with a single click, which gives AutoSign a great competitive advantage over other similar programs. And once we have created the entire model and equipped it with attributes, we can create different visualizations or construction simulations based on it. In order to be able to open the model from Plateia in other software solutions, we must first export it to IFC. I would like to ask you to quickly answer the question, of whether you have ever exported models to IFC format. I think that the question should now appear on your screen. Gregor, can you please share us the results? Okay, thanks everyone. I see that there are still some of you who have not done this before. So I will quickly explain what the IFC is. IFC is a standardized digital description for data interchange in the construction industry. This means that someone can work in a program A, export to the model export the model to IFC, and then open it in program B. Previously, when this option was not available, the procedure was as follows. The architect exported the plans to PDF, and the structural engineer had to draw the construction from the beginning in his software in order to make static calculations. Any such manual work leads to a great loss of time and also increases the possibility of errors. On this slide, you can see the Plateia model in the BEX program, which is indented for project management. The next slide will show us an animation made in the Lumion program. In this case, however, we do not need to export the model to IFC as there is a plugin for AutoCAD and BricsCAD. In Lumion, we add materials to Plateia's models and get realistic renders very quickly. Finally, let's take a quick look at roundabouts. When designing BIM roundabout, we can use similar approaches as we have shown today in the example of an intersection. First, we make a model of the circular part. Then we continue with the approaches. And finally, we draw the intermediate parts. A detailed demonstration of designing BIM roundabout model can be found in one of the following webinars, which will be held within 2 months. To sum up, I would like to invite you to follow our LinkedIn profile. To do so, please scan this QR code or click on the link in the chat. That way, you can always be informed about new webinars, tutorials, and success stories of our customers. There was plenty of material presented at this webinar. In the introduction, we have reviewed the development of the construction industry in recent years and learned about the BIM planning concept. The adoption of building information modeling is crucial for construction companies to achieve a competitiveness in the market. As we have walked through the intersection modeling process, breaking it down into 5 key steps. These steps are preparation, drawing of the intersection surface, drawing of projection lines, 3D model, and attributes. We have also looked at the process of creating islands and traffic signaling. I hope that today's webinar encouraged you to try to model an intersection yourself. As experts in your field, don't be afraid of new challenges because they give the best rewards.
Thank you, Petra, for this great presentation. Now just let me share my screen. Mhm. Just a second. Okay, I'll just try to wrap it up really quickly. Plateia has, as mentioned, lots of users by many companies, large and small, all over the world. Maybe some interesting information, what kind of license types it is available in. It is available as a single user software license or also as a network license, which can be shared in the company by many users. There are also various purchase options. It can be bought as a perpetual license with all the maintenance benefits as updates, upgrades, free technical support to emphasize, and with additional licenses for home use or use on the terrain. It can be bought also as a subscription with all the benefits of maintenance. Maybe I would, it is a good idea to take advantage of CGS Labs software trial. You can get our product for free testing for at least 14 days. The testing license is same as the actual commercial license, so it doesn't have any technical limitations. And then what you get also during your test phase is top-notch technical support that we provide. Our technical support is live by civil engineers who are very experienced, so they can help you also with the technical questions, not only the issues with the computer, but also they can consult you on the projects. Maybe to add that in a recent survey that we did among the users, they rated our technical support 5 out of 5 stars. So users really regard it as very good technical support. What we also have available, which is 24/7, is CGS Labs knowledge base. It includes all the instructions, user manuals, video tutorials, and this content is created daily through our technical support and added to the knowledge base. You can find it on our webpage. And also, Petra already mentioned the free online trainings, basic trainings, and I shared the link with you through chat box, so you can check it out and see if you can find these tutorials useful for your daily work. What I would like to invite you also is to follow our blog. This is blog on technical steps, instructions, issues when designing roads, railways, or river engineering. It covers all of our products, but you can easily filter through the blog and get the tutorials that you're looking for. As mentioned, we provide many resources for the users, YouTube channel, GoToState channel, which includes all our webinars, and LinkedIn is also a channel where we share a lot of technical information and tutorials and other webinars. Maybe now it is time, if you have any questions, we would like to try to answer them for you. You can quickly type here, or you can even send them to us later on, and we will try to contact you and maybe answer it through the emails. Let's check if we have anything. One asked, can I have a recorded session? Yes, as explained in the beginning, the session is being recorded and we will share it with you after the webinar once it's prepared. Here we have a technical question. Could you please create driveway in carb return area? We can't do a live presentation at this moment, but we can contact you and see what exactly do you want to find out about the software, and we can share it with you. Actually, there are no other questions. Then I would like to take this opportunity and announce some of other webinars that are planned for the rest of the year. First in line will be road reconstruction design, which is planned for the 22nd of September. And then, as Peter already mentioned, the BIM approach to the design of roundabouts, which will be ready in a couple of months. And we will also share this information with you so you can join us at this webinar. Yeah. So I think that this concludes the webinar. Thank you all for attending, and we hope you have learned something new and enjoyed these presentations. And also that the webinar was useful, informative, and that you enjoyed our company. And thank you again for your time. And for all other information, you can contact us directly. You can check our internet page, or you can contact any of our partners. Check if there is a partner in your country and give them a call, and they will give you all the necessary information about CGS Labs products and other useful information, trainings, and so on. Thank you again, and have a great day.